Hello. I wanted to talk with you guys just a couple minutes about making, about atoms and how they become an ion, right? And what this means regarding valence electrons and stuff. So I'm going to walk through a couple. I'm going to post this form on Google Classroom, and so you can print that out if you would like and follow along, or try to do it yourself once you see what we're doing. So lithium is number 3 on the periodic table. And if lithium is number 3 on the periodic table, that means that lithium, excuse me, that means lithium has 3 protons and 3 electrons. So, and lithium also sits in the second period, so it's ending electron distribution. So we're only concerned about the electrons in the highest energy level when we're talking about this. So we're talking about the last electron, right? So we would say that its ending electron configuration is, we'll put the energy level that it's in, it's 2s1, right? It has 2 other electrons in 1s2, but its last electron is 2s1. Then this gives us the number of valence electrons. This 1 right here tells us that we have 1 valence electron, and we know that lithium is in group 1, so it's in family number 1, or we also call that the alkali metals, right? So now, how does lithium become an ion? So we're going to look over here at our ion list, and we're going to decide, in order to become an ion, does lithium gain or lose electrons? So what we're going to do is evaluate right here. Is this number of valence electrons close, getting close to 8, because that's how many we would like to have, or for the octet, or 2 if we're thinking about becoming like helium. And so to become stable, so this is not stable. This 1 valence electron is not stable. So to become stable, to have the electron configuration of a noble gas, lithium is going to lose, so we'll circle lose, 1 electron. When it loses 1 electron, it's still lithium. So it still has 3 protons. But it lost an electron, right? It lost an electron, so now it only has 2 electrons. So if it has 3 positive charges and 2 negative charges, then its charge is a 1 plus charge. Right? So that's how we go through that process. Let's do another one. Let's just do another simple one here for beryllium. So beryllium is number 4 on the periodic table. So that means beryllium has 4 protons and 4 electrons. Beryllium sits in group 2. So its ending electron configuration is 2s2. So this means that in group 2, it has 2 valence electrons, and it's in family number 2. We also know family number 2 to be the alkaline earth metals. So now we ask ourselves, beryllium, right, with these 2 valence electrons, that's very far away from getting to 8. So beryllium is also going to lose electrons. It's going to lose 2 electrons. Now, how many protons does beryllium have? Well, that hasn't changed. That's in the nucleus. So we have 4 protons, but we've lost 2 electrons, right? We lost 2 electrons. We had 4, so now we have 2 electrons in beryllium. Beryllium's electron configuration is now identical to helium's electron configuration. So now, if we have 4 positive charges and 2 negative charges, we're no longer neutral, right? So here we had the same number of charges, so we were neutral. Now we have 4 positive charges and 2 negative charges, so we have a 2 plus charge for that ion. All right, let's do boron. Boron is number 5 on the periodic table. Boron has 5 electrons. Boron's ending electron configuration is 2s2, 2p1. So 1, 2, 3. We have 3 valence electrons. We are in family number 13. Now we know we moved up to 13 because groups 3 through 12, those 10 blocks in the middle, are the D block. So we're looking here with 3 valence electrons. Is boron is something with 3 valence electrons likely to lose or gain electrons? What would be easier? What would take less energy? And it would be less energy to lose 3 electrons to become stable. If it loses these 3 electrons, it's going to have a noble gas notation of like helium. And so now we evaluate how many protons does the boron ion have. It has 5 protons because it's still boron. That has not changed. The number of protons does not change. We lost 3 electrons. We had 5 to begin with. So this means we have 2 electrons now. This is more stable because this is an electron configuration that's identical to to helium. And we have a 5 plus charge and a 2 negative charge gives us a 3 plus charge. Now let's move to the other side of this, to making negative ions. So for now, I'm actually going to ignore carbon because carbon is, well, let's just put it in here. It has 6 protons and 6 electrons, and it's 2s2 and 2p2. So it has 4 valence electrons. It's in family 4. But what we're going to find out is it's just as easy to lose or gain 4 electrons, right? It could lose or gain. And so we might actually have a 4 plus or a 4 negative here. That's kind of beyond where we want to think about right now for carbon. So let's move on to nitrogen. Right? So let's look at nitrogen. Nitrogen, we're looking at nitrogen on the periodic table. Nitrogen has 7 protons. Its atomic number is 7. It has 7 electrons. Its ending electron configuration is 2s2, 2p3. All right, it sits in group, it has 1, 2, 3, 4, 5. It has 5 valence electrons. It's in group 15. So we're noticing that our group, our family number, and our valence electrons have a connection, right? So now, when we reach this tipping point, when we get past carbon, where we have 4 valence electrons, now we're halfway to the octet. So this is where atoms are going to begin to gain electrons in order to become an ion. So we had 5 valence electrons. To become stable, we need to gain 3 because now, instead of losing to become like helium, we're going to gain electrons to become like neon. Right? So now we're still talking about nitrogen. So we have 7 protons, but now we have gained 3 electrons. We had 7 electrons. We've gained 3. Now we have 10 electrons. How many electrons does neon have? 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. 10 electrons. That's the electron configuration we have now. What is its charge? Now let's think about this. If we have 7 positive charges and 10 negative charges, right? Then we are a -3 ion. The charge matches the number of electrons that were gained in order to get to that ion. Let's go to Oxygen has 8, 8, 2s2, 2p4. So we have 6 valence electrons. We're in column 16 or group 16. Now, if we have 6 valence electrons, we would need to gain 2 electrons. We're oxygen still, so we have 8 protons. 8 plus 2 is 10 electrons. So now we have 2 more negative charges than the positive charges that we had. We still have an electron configuration of like neon, so we're stable. So that's all good to go. So we can get these next 2 in here. Fluorine has 9 valence electrons. I'm sorry, 9 protons, 9 electrons. There's not a 9 valence electron. It has 7 valence electrons, 5, 6, 7, and it is in column 17. Now, if we have 9 valence electrons and we're trying to get to 10, or we have 7 valence electrons and we're trying to get to 8, right? 7 valence electrons, we're trying to get to 8, so we're going to gain 1 electron. We're still fluorine, so we have 9 protons, but now we have 10 electrons, just like neon, so we're stable. And now we have 1 more charge than we had before. Now, what happens when we get to neon? Neon has 10 protons, 10 electrons, 2s2, 2p6. It has 8 valence electrons. It's in group 18. It is going to gain or lose none, right? 0, because it is already stable. It has 10 protons and 10 electrons, so it is going to have no charge when we talk about it becoming an ion. So let me pull this up here and let you just take one more last look at the whole thing. Let me go back in and fill in this. So carbon would have 6 protons, and it would have, it could have a differing amount here. So if we were getting to a 2+ charge, we would lose 2 electrons, or we could gain electrons, right? If we were gaining electrons, if we gained 4 electrons, it would be 10 electrons to get us to this charge here. We're going to find that carbon really likes to share because it's halfway there. So don't let carbon mess you up when you're thinking about, so these are metals. Metals become positive ions. Non-metals become negative ions. What do we see happen? +1, +2, +3. -3, -2, -1. So we go up here in the number of electrons we're losing, and then we go down, right? 4 is our tipping point for where we can share. Hope this was helpful in getting you to understand why things become an ion to get to that stable electron configuration.